Today's lesson is 6.8. We're going to be doing patterns with fractions. Our essential question: how can you use addition or subtraction to describe a pattern or create a sequence with fractions? We've done this with decimals and we've done this with whole numbers. Now we're doing it with fractions. So let's unlock the problem. Mr. Patrick wants to develop a new chili recipe for his restaurant. Each batch he makes uses a different amount of chili powder. The first batch uses 3 1/2 ounces. The second batch uses 4 5/6 ounces, and the third uses 6 1/6 ounces. The fourth uses 7 1/2 ounces. If this pattern continues, how much chili powder will he use in the sixth batch? So we've got to the fourth, so we need to find out the fifth, and then we can find out the sixth. So you can use a pattern in a sequence by comparing one term with the next term. If we compare the first term with the second term, we'll find out what the difference is. Compare the second term with the third term, and we'll find out the difference. And the third with the fourth, and we'll find out the difference. And the difference between all of those should be the same. And if we continue to add those, so if I add whatever we find out between these, I would find out what the fifth term is, and then I'd have to do it again with the sixth batch. So step 1, we're going to write the terms in a sequence as equivalent fractions with a common denominator. Then we're going to examine the sequence to compare the consecutive terms to find the rule that they use to make this sequence of fractions. So I can't really compare them when I have a 2 on the bottom, a 6 on the bottom, a 6 on the bottom, and a 2 on the bottom. So I need to find a number that I can make all of them go into. Okay, so if I'm looking, I want to change the bottom numbers to be the same. So a number that they have in common is 6. I mean, I know 2 can go into 6, and the other ones already have 6. So that means I only have to change this one and this one, because these can stay the same. So batch 2 can stay 4 5/6, and batch 4 can stay batch 3 can stay 6 1/6. So this one is 7, and this one is 3, but I have to change the half on both of these. Well, if I'm going to make the half have a 6 on the bottom, in order to do that, I need to multiply the 2 by 3. So whatever I do to the bottom, I do to the top. So 1 times 3 is 3. So both of these halves are going to be turned into 3/6. So I'm just going to turn all these halves into 3/6. Now I have 6 on the bottom of all of these, so I can compare. Well, 3 3/6 and 4 5/6, the difference between that is 1 2/6. Right? Because if I have 4 5/6 and I subtract 3 3/6, I get 4 minus 3 is 1, and I get 5 minus 2 is 2, 2/6. Or you could say 1 1/3, right? But let's look and see. 4 5/6, the difference between 4 5/6 and 1 1/6 is also adding 1 2/6. Let's look at 6 1/6 and 7 3/6. Again, it's 1 2/6. Or you could say 1 1/3 if you're going to reduce it. So write a rule. Let's write a rule that describes the pattern in the sequence. Well, in the sequence, there are increasing or decreasing from one term to the next. Well, in this particular one, it was increasing, right? Because we added 1 2/6 or 1 1/3 each time, because each term was 1 2/6 or 1 1/3 greater than the term before it. So what is our rule? Well, our rule is going to be to add 1 1/3, or you could say 1 2/6 if you didn't want to reduce it. So now that we know what the rule is, we have to extend our sequence to solve the problem. So if our last number was 7 1/2, right? If our last number was 7 1/2, or we converted 7 3/6, then all I need to do is I need to add 1 2/6 to find out what this one is, right? So that would be 8, and 3 plus 2 is 5/6, okay? And then in order to find out my final answer here, I'm going to have to, I'm going to have to add the 1 2/6 to the answer that I got here, which was 8 5/6, and I'm going to get 9 7/6, okay? But remember, 7/6, 6 goes into 7 one time, so that would change this into a 10. So I would get 10 and 1/6. So my final answer is Patrick will use 10 and 1/6 ounce of chili powder in the 6th batch. Okay, so again, I have to find the unknown terms in the sequence, but before I can do that, I need to find common numbers on the bottom. Well, 4, 16, 8, 16, 16, and 4. A number that they can all go into, first I always look at the bigger number, 16. Well, can 4 go into 16? Yep. Can 8 go into 16? Yep. So 16 is going to be the number that I'm going to try and use on the bottom. Okay, so first I'm going to go ahead and write the ones that have the 16. I'm just going to leave them there. So this is 1 and 9, 16, because I decided 16 was going to be my bottom. This one is 1 and 3, oops, that one actually have to move, so this one's 1 and 3/16. Okay, and then I don't know those three, and I know this one is going to be 7/16. So first I'm going to convert the 1 and 3/4, and I want 16 to be on the bottom. So that means I need to multiply this by 4/4, making it 12/16. So this first one's going to be 1 and 12/16. So I did that one. Now I'm going to convert this one right here, the 1 and 3/8. So 1 and 3/8. In order to make the bottom be 16, I have to multiply by 2/2. 2 times 3 is 6, and 8 times 2 is 16. So I'm going to get 1 and 6/16. Okay, and then finally I'm going to convert my 1/4. And in order to change 1/4 into 16 on the bottom, I have to multiply it by 4/4. So that's 4/16. Okay. All right, so now I need to write a rule that's describing. So I've got them in a sequence, and so now I need to write a rule that is going to describe the sequence. So what operation can be used to describe the sequence that increases? Well, when something increases, we say we're adding, right? So we can say that the rule is going to be addition. Okay? And then what operation can be used to describe a sequence that decreases? Well, when we decrease, we subtract, right? So the rule could be subtraction. Okay? So we need to look at this. Is it increasing or is it decreasing? Well, I started with 1 and 12, is that 17/16? And then I had 1 and 9, 1 and 6, 1 and 3, and then down here we don't even have a whole number anymore. So we know that we're subtracting, right? So subtraction is going to be part of our rule, and we need to know what fraction we're subtracting by. So let's subtract. If we're looking at, that's actually a 12, sorry. If we're looking at this, the difference between this one and this one is 3/16, because 1 minus 1 is 0, and 12 minus 9 is 3. So let's see if that pattern continues. This one to this one. Well, 6 minus 9, there's 3 again. Look over here. 6 minus 3, there's 3 again. So I am subtracting, excuse me, I spelled subtract wrong there. I'm going to subtract 3/16, and that's how I'm going to get these three numbers. So now I'm going to use my rule, and I'm going to finish the sequence above. So if I want to find out what's going to go in these three spaces right here, I need to start with this number, 1 and 3/16, and I need to subtract, right here, I need to subtract my rule, 3/16. So if I subtract 3/16 from 1 and 3/16, I'm going to get the whole number 1. Now if I subtract 3/16 from that 1, remember a whole number could be any number we want. So I'm going to change this whole number so that it has 16 on the bottom. So I'm going to change it to be 16/16. That way I can subtract much easier. So if I have 16/16, that's my whole number because I changed it out, right? For fraction pieces. And I'm going to subtract 3/16. Then I'm going to get 13/16. And then if I subtract another 3/16 from 13/16, I'm going to get 10/16. And then make sure that the pattern continues. 10 minus 3 is 7, so that works. 7 minus 3 is 4, so that works. All right, so let's write the rule for this one. We have 1 and 1/12, 5/6, and then we don't know this number. We have to figure that one out. And we have 1/3 and 1/12. So first I say to myself, is it decreasing or is it increasing? Well, since it's decreasing, then I know my rule is going to involve subtraction. So I'm going to subtract something. So first I need to find the bottom. Okay, and I need to make them all be the same. So 12, 6, 3, and 12. A number that they all have in common is 12. So that means I'm going to have to change this 5/6. I'm going to have to change this 1/3. So I'm going to rewrite them out. I have 1 and 1/12. Now let's change the 5/6. In order to make it be 12 on the bottom, 5/6, I'm going to have to multiply by 2 over 2, and I get 10/12. So my next number is going to be 10/12. And then I don't know this next number. It's still a mystery to me. Now I need to change the 1/3 and make 12 be on the bottom. In order to do that, I need to multiply it by 4 over 4, and that's going to give me 4/12. Okay, and then this one already is in 12, so that's 1/12. So now I need to find out what the difference is. Well, 1 and 1/12 from 10/12. I can't take 1 from 10, but if I borrow the 1, remember, I did that in the last lesson, then I can make this one be 12 over 12 plus the 1/12, and I would have 13/12s. Okay, so then that means I'm now looking, I'm going to cross this out, I'm going to replace it with 13/12s. I'm looking at the difference between 13/12s and 10/12s. Well, that's 3/12s. Okay, oops, 3/12s. So let's make sure that that works. Let's look at 4/12s minus 1/12. Again, we've got 3/12s. So then that means if I subtract 3/12s from 10/12s, I should get this mystery number. So 3 from 10 is 7, so my answer is going to be 7/12. So the rule here is to subtract 3/12s. So now they want us to write the first, on B, they want us to write the first 4 terms of the sequence. So here's my rule. My rule is to start at 1/4 and then add 3/8. So if I start at 1/4 and I have to add 3/8, first of all, let me change my 1/4 to have 8 on the bottom. So that means my 1/4 is going to be 2/8. Okay. So then I add 3/8 to 2/8 and I get 5/8. And then I add 3/8 to 5/8 and I get 8/8, or 1 whole, right? And then I add 3/8 to that and I get 1 3/8. All right, share and show. Write the rule for the sequence. So we have 1/4, 1/2, 3/4. So I think to myself, is the sequence increasing or decreasing? In this case, it's increasing, so I'm going to add. Now I've got 4 on the bottom, and I probably want to change this to be 4, so that way I can have equivalent fractions. So that means I'm going to have to multiply 1/2 by 2 over 2, right? And if I do that, then I'm going to end up with 2/4. So now I have 1/4, 2/4, and 3/4. So if I'm looking, I'm increasing by 1/4 each time. So my rule is going to be add 1/4 or 1/4. Again, I'm looking at these. I have 9 on the bottom. So if I change this one to have 9 on the bottom, I have to multiply it by 3 over 3. So I'm going to get 3/9. So now I have 1/9, 3/9, and 5/9. So if I'm looking at my rule, am I increasing or am I decreasing? I'm increasing, so that means I'm going to add. And it looks like I'm adding, the difference between this one is 2/9, and the difference between this one is 2/9. So my rule is to add 2/9. All right, so I'd like you to complete the rest on your own. I'll be on the carpet if you need me. You can work with a partner. Good luck.